All right, so we talked about how air is a form of matter, right? Remember that matter is anything that has mass and takes up space. So air does those things. You know, here's a balloon with not much air in it. It's not taking up much space inside the balloon. There is air outside the balloon, which is why it's kind of squished in. But we add the matter of air into a balloon and it takes on a whole different shape, okay? So yeah, air is matter. And because air is matter, it does the same thing that any other type of matter can do. Water, it could change, it could be involved in chemical reactions and things like that because that's what matter does. Matter has chemistry. And air is the same thing. It has the same properties as any kind of matter. It's measurable and this and that. One of the things that all matter has in common is that on its own, it can't do anything. Okay? Matter is just what makes things. Energy, on the other hand, is what allows matter to do something. And energy is very different from matter because energy does not have mass. Energy does not take up space. Some examples of energy. Sound, okay? The light we see, movement, chemical energy, heat or thermal energy, like we see with this blowtorch here, right? So this blowtorch, you guys, that like blue flame you see there, guess what? That's not taking up any space. Yeah, okay. It has no mass. There's actually a lot of energy here. There's sound, light, and heat energy all happening at once. But matter could be there. I just didn't feel like burning my hands. But yeah, matter could be there because that's just energy you're seeing. But here's the deal. Like I said, when energy is given to matter, okay, the matter can experience a change. Matter could change its position. Matter could change its thermal energy or temperature. Matter could change into another type of matter. So energy allows matter to do different things and behave differently. Whenever matter is given energy, change is going to be measurable, noticeable, observable. So what I'm going to do is I have this setup over here, okay? And I have essentially two bags hanging in balance, okay, two brown paper bags. And each bag has an open bottom, okay, which means that right now, because air moves all around, there is air inside each of these bags. And what I'm going to do is I'm going to add energy to the matter in one of those bags, okay? So let me just get my energy. Okay, my energy this time is going to be a heat source, okay? And I'm going to just kind of add thermal energy to one of these bags. And you should be able to notice that some sort of change took place. The change that took place is happening to the air inside this bag. So the bag that was given thermal energy to, the air inside the bag that was given thermal energy, experienced change that the other bag did not experience. And because of that change, something happened, okay? This went out of balance. The one that was given the heat source was able to move up higher than the one without the heat source, okay? The one that was given more thermal energy moved up, and the one that did not get it essentially was comparatively moved down. So what we have here is, I changed the matter inside this bag. I changed the air inside this bag. It experienced change because it was given thermal energy, okay? Because a heat source was provided to make changes to the air particles, to the air matter inside this bag. How do we know that those changes occurred? Because we saw results. Like I said, you can't see what air does. Okay, you can't see the actual particles of air experiencing change. But when particles of air experience change, you could see what happens as a result of that. So again, matter can't do anything on its own. You add energy to matter, and matter has observable changes. You might not be able to see the matter itself change, but you could see what happens because the matter changes. There you go. So, matter and energy, okay, they work together. Thanks.